Today I will tell you about a simple introduction about how the equilibrium is set up in the phase rule, that is phase equilibrium. I will tell you about the phase equilibrium. So when we consider any system where there are many phases, then our system is said to be in equilibrium if properties like the temperature, the pressure and the composition of the various phases which are present in that system, these variables, they do not change with time. So in fact, when we are talking about phase equilibrium, there are mainly two types of equilibrium which will be encountered when we will study different systems over here. These two equilibrium are, one is the true equilibrium and another one is the metastable equilibrium. Now when we talk about true equilibrium, let us consider two phases in equilibrium. Let them be, suppose for example, let them be ice and water. So what will happen? Under conditions of under appropriate conditions of pressure and temperature, means suppose the temperature is, when temperature is 0 degree centigrade and pressure is 1 atmosphere pressure, then at that time ice will change to water. At 1 atm pressure, ice and 0 degree centigrade, ice will change to water, and the reverse is also true, means that water can also be changed to ice at the same conditions of pressure and temperature. Means the reverse equilibrium can be set up. There will be equilibrium. We can move from the forward direction, means ice can change to water, and similarly reverse is also true under the same conditions of temperature and pressure, means water can be easily converted to ice also. This means that a state of true equilibrium is can be reached by both the directions, means so this is the true equilibrium when the conditions of reversibility, means the condition of equilibrium actually can be reached from both the directions. Ice can be changed to water and water can be changed to ice. So this is a true equilibrium. Now let me explain the metastable equilibrium. Now one perfect example is water at -2 degrees centigrade. I have taken this example because you will study this example in the water system. You will study this curve in one component system of water, in sulfur also, and in carbon dioxide also. You will study this metastable equilibrium. So I have taken this example, water at -2 degrees centigrade. So just now, as we have seen that if we take ice, we at 1 atm and 0 degree centigrade, we can easily convert it to water, and water will be converted to ice. But if the state of equilibrium is attained only from one direction, and that too by careful change of conditions, then a metastable equilibrium is said to be set. Means we can have this water at -2 degrees centigrade by careful cooling of water only, but not by the melting of ice. Suppose we are having ice and water, and we can imagine that ice will change to water, and we can get water at -2 degrees centigrade. That is not possible. Only by the careful cooling of very careful cooling of water at 0 degree centigrade, we can get water at -2 degrees centigrade, but we cannot get water at -2 degrees centigrade by melting of ice. So this is the metastable equilibrium when we are considering the phase equilibrium. So now I will tell you about the criteria which are required for phase equilibrium in a multi-component system. Suppose there are many components, then what we require, what are the criteria we require for the multi-component system. Now, as we all know that a phase equilibrium, it involves a number of phases and there can be a number of components. So what is the criteria for phase equilibrium for a multi-component system? Means what are the conditions which must be satisfied for a phase equilibrium? which involves many components. So there are mainly three criteria. One is the thermal equilibrium, another is the mechanical equilibrium, and one is the chemical. So when we talk about thermal equilibria, so this condition implies that the temperature in every part of the system must be the same, because if temperature is not the same, what will happen? The heat will flow from one part of the system to the other. So this condition shows that the temperature of, suppose there are two phases, then the temperature in phase A should be equal to the temperature in phase B. So this condition should be satisfied. Another one is the mechanical equilibrium. So this condition implies that pressure in every part of the system should be same. Otherwise, what will happen? That matter will flow from one part of the system to the other. And when matter will flow from one part of the system to the other, then there will be change in the Helmholtz free energy. So, for mechanical equilibrium, the pressure in, suppose there are two phases, then the pressure in phase A should be equal to the pressure in the phase B. Now let's come to the chemical equilibrium. So chemical equilibrium is actually the thermodynamic criteria for phase equilibrium. So as we all know, let's suppose there are two phases A and B. This is phase A and this is phase B. And since it is a multi-component system, let's assume C1 be one component and C2 let it be another component. C1 and C2, C3, and suppose there are Cc number of components, and there will be an equilibrium between these components. Now let the chemical for component 1, let the chemical potential be mu1 for component 1. For component 1, let its chemical potential be mu1. Actually, we denote the chemical potential by the symbol, Greek symbol mu. So let for component 1, the chemical potential is represented by mu1, and likewise for component 2, it is mu2. For component number 2, it is mu2, and for component 3, let it be mu3, and let for an ith number of component, let it be mu I. So this chemical potential mu1 for phase A should be equal to the chemical potential of the component number 1 in phase B when they are in equilibrium. Means chemical potential of component 1 for phase A should be equal to the chemical potential in phase B, and it should be equal, suppose there are not A and B, it is a multi-phase system, there are A, B, C and D till pth phase. So the chemical potential of phase 1 of component 1, and it should be equal to similarly chemical potential in the pth phase. Means the chemical potential of the component should be the same in all the phases. So this is for a simple system in which only two phases are present, but if there are many phases, then this equation will hold true. This is for component number 1. Suppose we consider component number 2, likewise it will change. mu2 for A phase is equal to mu2 for B phase is equal to mu2 for C phase. And similarly, suppose there are I number of components, then mu I for phase A will be equal to mu I for phase B. Similarly, this will again be equal to mu I for phase C and mu I for the pth phase. So this is all about for multi-phase systems. and for multi-component system. So for multi-phase equilibria containing a number of components distributed among them, the chemical potential of any component is the same in all the phases, as we have seen here. So let me summarize this all once again. Let me summarize this once again. So this is the criteria for the phase equilibrium in a multi-component system. As we all know, a phase, when we study the phase system, we find that it will have many components also, not only one or two components, there are many components also. So what are the criteria? Are that there should be thermal equilibrium, there should be mechanical equilibrium, and there should be chemical equilibrium as well. As far as thermal equilibrium is concerned, this condition implies that the temperature of in every part of the system must be the same, otherwise heat flow will take place from one part of the system to the other. The second condition is the mechanical equilibrium. This condition implies that the pressure in every part of the system should be same, otherwise matter will flow from one part to the other and there will be change in the atmosphere. So pH should be equal to PV if we are considering two phases A and B. Now comes the chemical equilibrium. If we consider two phases A and B, and since it is a multi-component system we are considering here, C1, C2, C3 and this C. So the chemical potential in all the phases of a particular component should be the same. So this is all about criteria for phase equilibrium of a multi-component system, in which we find that the chemical potential of any component is the same in all the cases. Thank you very much.